How's it going, everyone? This is 4.2 Triangle Congruence by side, 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 and side, angle, side. All right, so for your do now, they want you to mark the triangles below given their congruence statements. Okay, they tell you angle F is congruent to angle J. Angle G is congruent to angle K. Angle H is congruent to angle L. Side FG is congruent to JK. GH is congruent to KL. And FH is congruent to JL. Okay, here's your first postulate, side, side, side postulate, or SSS. Okay, if the three sides of one triangle are congruent to the three sides of another triangle, then we can say that the two triangles are congruent. Okay, so three sides congruent to three sides, then we can say the two triangles are congruent. We don't need to look at the angles at all. Okay, so using side, side, side. We're given this picture here, which takes a piece of the roller coaster track to analyze, and we have our two triangles, okay? So, we have a given of LM is congruent to NP, which they show with one tick mark. Then LP is congruent to NM, which is shown with two tick marks, all right? So you have one side congruent to one side, another side of each triangle congruent to each other. And now lastly, these guys share a side in the middle. So when you share a side, I've always had to put an X on it, okay? And now here's our proof. We have LM is congruent to NP. Well, that was our given. Our other given was that LP was congruent to NM, which was a given. Now we have the last one where I just drew the X over. Side LN on the angle is congruent to itself. And when something's congruent to itself, remember we put an X on it because it is reflexive. Therefore, since we have 1, 2, 3 sides, side, 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 we can say that the two triangles are congruent. Okay, more practice. All right, we're going to fill this out as a traditional statement and reason T-chart, okay? Traditional proof. So our first given is that BC is congruent to BF. So let's mark that and we're going to write it down. BC is congruent to BF. And the reason? Well, that was a given. Then we're going to mark that CD is congruent to FD. And that's a given. So we have one side, here's S. We have a second side, and now we just need the third. Well, the third side is side BD, which both triangles share. So I can set BD congruent to itself. And now it's not a given statement anymore. When something's congruent to itself, we place an X on it because it is reflexive. Okay, so we have all three sides now. Side 1, side 2, side 3. And I can say that triangle BCD is congruent to triangle BFD. And that's by the side, side, side postulate. And there's your proof. Okay. You can also show relationships between a pair of corresponding sides and an included angle. Included. The word included refers to the angles in the sides of a triangle as shown to the right. So an included angle is in between two sides. So angle A is included because it's in between side BA and AC. You could also look at an included side instead of an included angle. And that included side, BC, is in between angle B and angle C. Okay, so included means in between. So now you have side, angle, side, which is exactly what it says. Instead of proving three sides, you need a side, an included angle, meaning in between, and another side. So if two sides of and an included angle of one triangle are congruent to two sides and an included angle of another, then the two triangles are congruent. Okay, so notice how you have a side, an angle, and a side. A side, an angle, and a side. And the angle must be in between. So here's our example. We have a given that QS is congruent to RT. QS and RT. So let's write that down. QS is congruent to RT. And that's a given statement. Our other given statement is that angle QSR is congruent to angle TRS. So QSR is this angle, and TRS is this one right here. And again, that's a given. So we have a side, we have an angle, and now we need one more side. And again, if we were to follow this path, we would need side SR, which is shared by both triangles. So SR is congruent to SR. And when it's shared and we place an X over it, that means it's reflexive. Okay, so now since we have side, angle, side, we've proved all three, I can say that triangle QRS is congruent to triangle TSR by the side, angle, side postulate. Okay, so you guys on your own, why don't you start with this one? Do your givens. AB is congruent to CD, and make sure you write them in. And angle BCA is congruent to angle DAC. And you're trying to prove triangle ABC is congruent to triangle CDA. And remember, your last side is going to be that reflexive side AC. So why don't you try and fill out 4 on your own, and I will check your answers when you submit your work. Number 5. Would you use side, 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 or side, angle, side to prove the triangle's congruent? If there's not enough information, write that there's not enough information. Well, if you look at the first one, I have side 1 and side 2 with an angle in between. In the second triangle, we have side 1 and side 2 with an angle in between. So that's going to be side, angle, side. But if you look at B, you may be inclined to write side, angle, side, because again, you see a side, two sides with an angle in between. But if you look at your second triangle, your side is in the wrong spot, or your angle is in the wrong spot. It should be here, but it's not. So this is not enough info. Here we have side 1 with side 1, side 2 with side 2, side 3 with side 3. That is side, side, side. And here we have side 1, side 2, and side 3, side 1, side 2, and side 3, side, side, side. But what else do we have? If I was to look in here, I would notice that we have a bow tie or vertical angles. So technically, this could be side, 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 or side, angle, side. All right, and for your exit slip, it says name the postulate you would use to prove the triangle's congruence. Okay, so we need to label what we know about each of these triangles. We have givens, side 1 and side 1, side 2 and side 2. Same over here. Except this image on the left, you have a pair of vertical angles, and the image on the right, you have a shared side. So tell me which postulate I would use for each of these, and I'll check your answers when you submit. Thanks for watching.